What's up, geometry students? We are going to look at more things in the coordinate plane, areas in the coordinate plane, uh, lines, intersections, all that good stuff. We are going to also review function notation, understanding if you have a function. It's just notation for like a very specific program where we can distinguish between two things. If I have my function is 2x plus 4, and if I ask you to find f of 0, well, let's say if I had two equations, an f and a g, um, it's a very easy way to distinguish which one we're going to deal with. You don't want to have two y equals, um, because then it's like, oh, what's y when x equals 0? And you'd be like, which y are we talking about? So this is why we use function notation. So we'd be able to plug in and get a value, or set it equal to a value. We could say if f of x equals 0, x would have to be -2. But with graphs, we'll start with this. We would say this is some function. Okay, we'll call it f of x. And what is f of 0? So when x is 0, what is the y value? When x is 0, my function is at 4. And this would be my answer to f of 0. And then if f of x equals 0, the question is, what is the x value when like the y coordinate is 0? Okay, and it's very easy. You just look at when y is 0, and you can see I got x equals -4, x equals 1, and x equals 6. Just good review of function notation and in the graph. And then the other question is, what is the area? So we're just going to have to be diligent about splitting this up into different types of triangles, looking at the y coordinates and x coordinates and distances. We don't have to find the perimeter, thankfully, but I could have asked you that. And it's just a bunch of 1/2 base times height. So this is 6. This is a rectangle with a uh, triangle on top. It's a trapezoid. There's a formula for a trapezoid, but we can just say this is 8, and this is 1/2 base of 2, height of 2. So this is 2. Here we got this base of 1, height of 4. So this is going to be 2. I'm going to take this, which I'm going to say is a base of 4, height of, or base of 1, height of 4. So this is also 2. Then I got this last triangle, which is 1, 2, 3, 4 by 1, 2, 3, 4. So 1/2 base times height is 8. So I have 10, 20, 10, 20, 28. There you go. Cool. Let's go straight into this. We can see this is a semicircle. We'll call this a function, f of x. This is a semicircle. We have a radius of 2, which means this half semicircle is a half of a pi r squared. So pi times 2 squared divided by 2. So that's 4 pi divided by 2. So that's 2 pi here. Here we have this triangle, which is a base of 2, height of 2, which is 2. And then we have this rectangle slash square and this triangle. So I have 2 pi plus 3.5. If x is 6, what is y? 2. If y is 0, what is x? 0 and 4. Let's find this triangle, this triangle. Ooh, this is tricky. Watch, because this is a 1, 2, 3, 4 by 1, 2. This is a slope of 2, which means I'm going to go up 2 over 1. Or you could say that's up 1 over a half. I'm going to divide the top and bottom by 2. And you could probably just like figure this out. But if I go up 1 over a half, we can figure out that this x coordinate is at a half. And then, so this triangle is going to be a half. It's a base and height of 1. So 1/2 base times height. This triangle is also going to be a half, so I can combine that to be a 1. This triangle is going to be a half by 1, so it's going to be a quarter. I'm going to say this is one big triangle, which is 1.5 by 3. So I have 1.5 by 3 divided by 2. So I got 9 halves divided by 2, or 9 halves times a half, which is 9/4. So this is 9/4. Ooh, this is tricky. And then finally, the hardest part is, what is this area here? Well, it's very similar to kind of what we saw last unit, where sometimes we want to find the area of an entire object and then subtract the area of a circle. And that's what we're doing here. Let's find the area of this rectangle. The area of the rectangle is 1, 2, 3, 1, 2, 3. So it's 9. And then subtract the area of the quarter circle. The quarter circle is a radius of 1, 2, 3. So it's pi times 9, 9 pi, but then divided by 4. Woo! So here's all the areas. I got a half. I got another half. I got a quarter. I got a 9/4. And then I have a 9 minus 9 pi over 4. And I think a lot of you won't really be comfortable with like between the x-axis, but like maybe the first thing we should do is highlight and make sure we see the betweens. That's what the betweens look like. All right, and so I got 1, I got 10/4. So 4/4, 10/4, 14/4, plus 9 minus 9 pi over 4. This is 12. This is 7 halves. This is 18 halves. So 25 halves minus uh minus 9 pi over 4. Just combining all my numbers. Many of you will not be comfortable with that, but that's what it is. We have to practice it. Great. I think it says O, meant to be f of 0. When x is 0, y is -1. When y is 0, x is -1, 1/2, and 5. Cool. Challenging question for you guys. More challenging questions. Finding the area of some regions. Well, guys, the key to these problems is intersections, okay? Y-intercepts, x-intercepts. This is x equals 0, this is y equals 0. Let's talk about region 1. Well, I can see there are these 1, 2, 3 points that make my triangle. I can see that the triangle's not right, so I got to figure out this length here and this length here. To figure out these lengths, I need to find these x-intercepts. Well, this is obviously the point 0, 0. No big deal. This would be taken from y equals 5 minus a half x. And if I plug in an x of 0, I get a y of 5. It is just an easy way to find the intersection. Now, the last part is, where do these two lines intersect themselves? And I am going to figure out, when does y equal 5 minus a half x intersect with y equals 1/3 x? And we don't want you to use your calculator to do this. We don't want you to graph with Desmos. We want you to solve this equation. We are figuring out the x coordinate where the y's equal each other. We'll find the x and the y this way. How I'm going to do this, I have to add my like terms. Great. I need to take 1/3 and add a half. I'm going to turn 1/3 into 2/6. I'm going to turn a half into 3/6. So I get 5/6 of an x. I'm going to multiply by 6, divide by 5. I get x equals 6. Now, Great. This is x equals 6. What is the y? Well, if you plug in 6 in for x, you get a y of 2. If you plug in 6 in for x, 6 divided by 2 is 3. 5 minus 3 is 2. Now you have everything to find region 1. We have this length from 0, 0 to 0, 5, obviously 5. And then we have this length, which we can see is a length of 6. So we end up with 15 as our region 1. Okay, region 2, same deal. We just have to find this height. We have this height. This height is 2. You can see the y coordinates 2. But we have to find this x-intercept when the red line, 5 minus 1/2 x, has a y coordinate that equals 0. We solve this, whether it's in this side or that side. We are trying to figure out all of these locations. How do I solve this? I'm going to probably add the 1/2 to both sides, 1/2 x to both sides, or I could subtract the 5. Honestly, subtract the 5. And I get negative 1/2 x equals negative 5. What do you do to solve this equation? Well, I like to multiply by negative 2. You might like to divide by negative 1/2, but I get x equals 10. So this point is 10, 0. Now you can see region 2 has a base length of 10 and a height of 2, which means its area is 10. Cool. Same deal. Let's just find some points. We can see this is 0, 0. That's nice. We can see if I plugged in 0, I get 5 again. Great. We need to find this intersection. We need to find this point as well. We need to find when negative 2/3 x plus 5 has a y coordinate of 0. So finding this point right here. What up? I won't drop your name. Don't worry. I won't drop your name on the video. And we got to figure out when. So I'll just like draw lines to the intersections. And we got to figure out when negative 2/3 x plus 5 intersects with a quarter of x. Cool. Let's do this one. I'm going to subtract 5. I'm going to multiply by 3 and divide by 2 to get negative 15 halves. Negative 15 halves is 7.5. Sorry, positive. Times 3 divided by negative 2 times 3 divided by negative 2. So 15 halves. If you want to change it into 7.5, that's great. But I wouldn't. You don't have to. We'll just embrace that. We got this one. We got this one. Now we got to find this one. All right, so I'm going to add the 2/3 of an x to both sides. I need to add a quarter and 2/3. I need a common denominator. I'm going to multiply the top and bottom by 3 to get 3/12 x plus top and bottom by 4, 8/12 x, and I get 11/12 x. So 5 equals 11/12 x. I'm going to solve for x and get 5 times 12 divided by 11. 12 times 5 is 60. So 60 elevenths. Great. That's the x coordinate. What's the y coordinate? Well, either this equation or this equation. If x is 60 elevenths, I'm going to divide that by 4 or multiply by 1/4. It's going to be easier to figure out the y coordinate if you plug it into that equation. So I get, divide the top and bottom by 2 because I don't know what this is. 30 over 2 times 11. I got 15 over 11. So 15 elevenths. Cool. Great. Lots of work to be done to do all of these problems. Expected for you to be able to figure this out without a calculator. If you have a calculator, fine, but leave it like this. Let's look at region 1. we have 1/2 a base of 5, and then my height is actually this x distance. This x distance is 60/11ths. So I have multiplying anything in any order. I'm going to multiply the half by the 60/11ths, and I'm just really going to divide the top and bottom by 2 to get 30/11ths times 5. And then I multiply those together to get 150/11ths. Region number 2, base is 15/2. Height is 15/11ths. 15 times 15 is 225. Yep. So 225 over 11 times 2 is 44. Cool. A lot of you probably don't feel comfortable with these as your answers. You'd like want to check. I'm just going to show you like how to check. And I want to check anyways. And this is not going to be something you're going to be able to do on your like quizzes and stuff, which is use Desmos. Cool. All right. That's a crazy point, but I think that point is 60/11ths. Comma 15/11ths. And look at that, found that. We had this point here, 7.5. We got that. It's your 15/2 0. Cool, we got that. We have this point right here. And if you want to do the work, it's like 1/2 base times the height, which is the x coordinate. That 16.363, which I say is 150/11ths. There you go. And then the other one is 1/2 my base length, which was 15/2. Then my height, which was 15/11ths, which I get is 5.1136, which I said was 225/44ths. There you go. Cool. This one is like the easier one. We just have to focus on y equals 2/5 x plus 3. We can just figure out when x is 3, what is y? When y is 8, what is x? We have this point is 3, 8, and let's do some work. If x equals 3, I'm finding like f of 3. I get 2/5 times 3 plus 3. So I get 6/5 plus 3. It's 15/5 plus 6/5, which is 21/5. When x is 3, y is 21/5. You need to be comfortable doing this work and getting the answers. When y is 8, you got 2/5 x plus 3 equals 8. Subtract 3, I got 2/5 x equals 3. Multiply by 5, divide by 2. X is 15/2. Cool. So doing that work, which you have to understand how to get the points. We now find the area. 1/2. What is this length? Okay, well, this length is tricky. I go from 21/5 to 8. I have to subtract 8 minus 21/5. Well, 8 is 40/5 minus 21/5, which is 19/5. So this is one place where this problem's a little bit harder, actually. And then if I'm going to 3 to 15/2, I should do 15/2 minus 3. Well, that's 6/2. You know this is 7.5. 7.5 minus 3 is 4.5, or 15 halves minus 6 halves is 9 halves, which is also 4.5. So 1/2, my base length of 19/5, my height of 9 halves. It doesn't matter which one goes in which order. We're good. Oof. It's not going to be nice. I have to dig out 19 times 9, which is 81. 171 20ths. Double check if you wanted to. Just make sure we have the correct intersections and everything. X equals 3, y equals 8, and y equals 2/5 of an x plus 3. We have this point, 4.2, which is 21/5. Great. We have this point, which is 15 halves, 8. Great. And then we have this point, 3/8. And then we find these lengths, 8 minus 4.2. And then 12.5 minus 3. Okay. You got y equals negative x plus 4. Just going to kind of sketch these. I'm not going to be perfect with them. I'm going to say this is y equals negative x plus 4. I know we're going to go down 1 over 1. I know I have the y-intercept of 4. We're good. Now we got y equals x plus 6, which will look something like that. I hope I gave you good intersecting points for this question, because this question could be hard. Then y equals negative 4x plus 10, which looks like that. Now, this is a right angle because this and this have opposite reciprocal slopes. So, to find the area of this triangle, I need to find two diagonal lengths. This diagonal length and this diagonal length. Now, how do I find said diagonal lengths? Well, the first things first is you got to find the intersections of everything with each other. So we need to figure out when this equals this. Going to subtract 4 divided by 2, I get x equals 1. So this is 1, comma, plug in 1, you get 3. Ooh, that's not right. Okay, got it. I made a mistake. Subtract 4, subtract x, you get negative 2x equals 2. You get x equals negative 1. So this is negative 1. What's the y coordinate? If you plug in negative 1, you'll get 5. If you plug in negative 1, you get 5. That checks out. The next one is I have to figure out when x minus 4, negative x plus 4 intersects with 4x, negative 4x plus 10. I add 4x, I get 3x. I subtract 4 from 10, I get 6. I get x equals 2. If x equals 2, y will equal 2. If x equals 2, y will equal, yeah, that's going to be 8, negative 8 plus 10, 2. Great. And then the last two is the negative x plus, oops, this is 2 down here. See, this is, I don't like these arrows. It's really screwing me up. This is y equals x plus 6. It's going up. This is y equals negative x plus 4. That's going down. This is y equals negative 4x plus 10. That's going down. Okay. When negative 4x plus 10 intersects with negative x plus 4, we're going to be down here. We get negative 3x equals negative 6, we get x equals 2. When you plug in x equals 2 into either equation, you get y equals 2. Now I need negative 4x plus 10 and x plus 6. Cool. Shoot. Darn. I did not intend that to happen. I wanted the numbers to be nice. But whatever. Why don't we just change it to 0.8? 0.8 and 6.8. Is that right? Did that not work out? Yep. Darn it. Well, why do I say darn it? It's because we know we have to do a lot of work now. Why? How do we find these diagonal lengths? Well, it's not easy. It's just up and down. We got to realize that you have to use the Pythagorean theorem. Okay. So we go from negative 1 to 0.8. That's 1.8 right here. We go from 5 to 6.8. That's also 1.8. So I'm going to have this length as 1.8 squared plus 1.8 squared square rooted. And why don't we use a calculator for that? And if you don't have a calculator, it's great. You can just leave it as that. All right, 2.545. Now, from this to this one at least is easy. This length goes from 5 to 2, so this length is 3. This is negative 1 to 2. This length is 3. That works out nicely. So we have this length here is the square root of 9 plus 9, which is the square root of 18, which is 3 root 2. So we have 1/2 this length times this length. Because it's a right triangle, it works out nicely. And the area is 5.4. Look how nice that works out. How does that work out so nicely? How does that work out so nicely? Now, this is not a right triangle. The slope of this is, and it's good to find the slopes. The slope of this is up 3 over 1, so the slope of this is 3. You can see you go up 3 over 1. This is going to be important to what we're about to do. The slope of this going over 4 down 2, so that's going to be negative 2. And then this is over 5 up 1. So they're not right triangles. So how do we find the area if it's not a right triangle? Well, I see triangles here, and I see a rectangle here. You can see the rectangle is a 5 by 3. I could find the area of the rectangle. And I have 3 triangles that I can easily find the area of. Well, let's find the area of those triangles. I got a 1/2 3 by 1. I have a 1/2 4 by 2. And I have a 1/2 5 by 1. So I have a 3/2 plus a 4 plus a 5/2. 8/2 is 4. I got 8. Okay, like 8/2 plus 4 is 4 plus 4, which is 8. Yo, the area of the rectangle minus the area of the yellow triangles gives me the area of that nice triangle in the middle, which is actually a beautifully easily found number. 7. Totally giving you that on a quiz next class. Entrance ticket, great questions. Just a really beautiful question that Mr. Pass came up with / knows of. All right, hope you enjoyed. I'm sure a lot of you have problems and need help, but that's what we're here for. Peace.